Hi, this is swathiramya, Assistant Professor, AIDS Department, SNS College of Engineering. You are here with me in IOT lecture series. So, in the previous class, we were discussing about what is IoT, what all the basic components of the IoT and how IoT has been used in the real-time applications, and we have been discussing about the few interfaces in the physical design of IoT. Let me always start with what is IoT. IoT is nothing but we have n number of devices, and these devices has been termed as thing, and these devices has been connected together, and these devices will communicate without the human interference. That is the main goal of IoT. So, what is purpose of connecting all the devices together and communicate with each other is ultimate goal of IoT is to make the things automated, make the function automated, so that the human, without the human interference, the devices will communicate and they can do by itself. So, this is the entire logic behind IoT. So, we have discussed about the physical design of IoT. We have got few interfaces of IoT. As previously we were discussing the connectivity, processor, audio video interfaces and input or output interfaces. See, connectivity. In the connectivity, you have got two ports, USB and RJ45 Ethernet. We have been discussing in the previous sessions very clearly. And the processor, obviously the purpose of processor is always a common thing. It will control entire operations. It will give you the instruction what devices has to do and when to communicate, where to communicate. This will be, and what all we going to do with the data that has been collected with the help of sensors and actuators. So, this is the purpose of processor, that you will have CPU, central processing unit. So, next thing will be audio video interfaces. You see IoT will not connect only the numerical data, it will have the data like images, videos, audios. So, we need audio and video interfaces. So, for that we have three things: HDMI 3.5 mm audio. For audio we will use 3.5 mm audio. For audio and video we will use HDMI, and olden days we will use RCA video. This is for olden things. Okay. Next comes input and output interface. Input and output interface, you have two kind of data in it: asynchronous data and synchronous data. If you want to use transfer a synchronous data, you will use UART. If you want to transfer the synchronous data, you will use SPI. If you want to transfer synchronous data but within the circuit, then you will go for I2C. Okay. If your data has been transferred between the microcontroller without the common host, without the intermediate host, then you can use for CAN. Okay. These all the things we were discussing about the previous two videos. In this video, we are going to discuss about, we collected the data using input output interfaces, and these data can be of any format, audio video. For that you have got audio and video interfaces, and these will be transferred using connectivities, any of one connectivities. So, where you will transfer the data, there comes the things. Okay. For that you need interface. So, for that we have got two interfaces, memory interface and also storage interface. So, we will start with the memory interface. For the memory interface, you have two things. One is NAND, NOR, and also DDR1, DDR2, DDR3. So, start with NAND and NOR. These are the type of the flash memory used for storing the data. NAND flash is commonly used for high density storage, while NOR flash is used for port storage and execution due to its faster read and speed. Okay. This is the use of NAND and NOR. So, when you go for DDR1 and DDR2, DDR3. DDR1 is nothing but double data rate. DDR means double data rate, which is used for dynamic data, dynamic random access. See, for DDR is always used for dynamic random access. This is a type of RAM. Which is termed as dynamic random access memory, used as a volatile memory to temporarily store your data that the CPU needs quickly access. So whenever the CPU needs to access the data very quickly, you put the data in this. This is dynamic random access memory. Okay, this is have the NAND and the DDR1 and DDR2 has been used for. This is a temporary DDR1 and DDR2, 3 all temporary memory space where the CPU will put all the data which is being currently used. It is like a tab you will see in your mobile. Okay, you have your tabs, right? 1, 2, 3, 4. Whenever you want, you can take the data from the tab, but that was temporary. That will not be a permanent data storage space. So next we are, after the memory interface, next we are going for the storage interface. It is a very traditional storage interfaces. So you will have SD card, card, SDIO. SD is nothing but you might be know very well. It is a secure digital, a storage interface used for removable flash memory cards. It's widely used for data storage in IoT devices, and we also use SD cards. So same thing it will be here also. Okay, then MMC, multimedia card, is similar to SD card. You have multimedia. MMC is a type of memory card used for the storage in a portable devices. This also SD card and MMC card is well known thing. And third thing will be SDIO, which is nothing but secure digital input output. It's an extension of SD. From the name it is very clear. It is an extension of SD card which supports both the memory and input output function. It supports for memory for storage and also input output functions. It's allow for the additional peripheral connections like Bluetooth and GPS module. See, it's an extension of SD card. It will give extra function as input and output function. That's why it's called SD input output IO. Okay, this is how the purpose of storage interfaces. Next we go for graphics. Graphics, you have GPU. Same, actually what is the purpose of CPU? So there comes the GPU also, graphics processor unit. It will control all the graphical things. That is the work of GPU. Okay, with this you have a clear idea about the block diagrams of physical design in IoT. So with this it is very clear that what all the components in the physical design of IoT and how it works and how it supports the IoT system, how it supports the IoT system, in what all way it's supporting the IoT system. Okay, with this I will wind up this session. In the next session we will discuss about the logical design of IoT. Bye bye, see you.